What we're going to learn here today is how to construct a frequency distribution based on raw data. So that's what we're going to be doing. So you want to get out these notes here. I handed them to you on day one. So you want to have these out. That's what we're going to be working from. I'm also going to show you how to do this on the calculator as well. So when working with large data sets, it's very helpful to organize and summarize data by constructing a table called a frequency distribution. Now, we're going to learn how to use various computer software items, namely StatCrunch. Namely, we're going to use StatCrunch in this course, but we're also going to use the graphing calculator. So we're going to start off with a frequency distribution or a table and to see how a data set is partitioned among all several categories. Now again, those of you that had emailed me earlier, anyway, a frequency chart, we're going to have lower and upper class limits. Those are the smallest and the largest numbers. Now, we're only going to be dealing with data that actually has, that's whole numbers, so don't worry about decimals or anything like that. We're going to have class boundaries because the purpose of class boundaries, it's going to eliminate the gaps. Basically, you would just subtract a half from the lower limit and add a half to the upper limit. And class midpoints, I'm not going to emphasize as much here, but the boundaries are going to be much more important. And here's another big thing, class width. It is a difference between two consecutive lower class limits or two consecutive upper class limits. It's a little typo here. So we can determine this using one of two ways. We're actually going to use, there's going to be one situation where you're going to be told to use, you're going to be told the class width and told where to start. And this works for distributions where you'd want to predetermine boundaries such as the event of grading or costs of items. Or option 2 will be where you are given the number of classes and be expected to determine the class width manually. And that seems kind of tough, but it's actually not going to be too bad. So frequency is the count or how many of a particular occurrence. So why do we construct these frequency distributions? So that we can summarize large data sets, analyze the nature of data, and we also get a basis for constructing important graphs. Yeah, this is going to be a lot to stomach here, but don't worry. Now, we're going to be able to sort the data using the calculator and or StatCrunch. So if you look here at page 2, this actually shows you how to enter data and sort it. Now, we're not going to use that data just yet. Actually, no, we will. So what I want you to do here, we're going to use this data here and we're going to enter all 50 pieces. Now, what happens here when you go to the calculator and go to Stat and Edit, you'll see that it's blank. Now, I get a lot of people that get confused. You need a calculator? Yeah, absolutely. That's why they're there. Don't worry. That's why we have them here. So anyway, here's what's going to happen. I get a lot of people that would look at this, all these columns of data, and they would see, oh, I have to enter these across 10 columns. No, 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 no. You are basically going to enter all 50 pieces of this data into list 1. And it doesn't really matter what the order is because we're going to put it in ascending order anywho. So yeah, I'm starting with 90, then I would enter 135, 400, 201, 350, 73, 325, 257, 157, and 250. Now, here's the thing. So far, I have entered how many pieces of data? 10. Now, the nice thing is, this is list 1, and that value of 10, that means that is the 10th entry on the calculator. That's the 10th entry. So, you take a few minutes and enter the rest of these. Okay, so how do you clear out a column? What you have to do, it should actually tell you how to do it in these notes. Let me see. Yeah, highlight the list you want and hit clear. Do not hit enter. No problem. And so far I've entered 30 pieces of data. Now, let's say you put in the wrong value somewhere. Let's say, I know I put this in right, but what you can do is, let's say I made that just 1,500. Okay, there's no GPS in this world that should cost $1,500 today. What you can do is very simple. Just highlight it and re-enter a value of 150. Go ahead and enter the last 20 pieces of data. Entered all 50 pieces of data. Now, so here's the thing. A slight little problem that we have with this is the data is not in order, but we're going to fix that. So what we can do is, if you look at step, starting with step 10, or actually step 8, here's what we're going to do. First off, I'm going to quit out of this, and I'm going to go to stat. Actually, no, I'm going to actually do this. I'm going to hit second and stat, and I'm going to go to ops. And if you notice, you have sort A and sort D. A, sort A, means we're sorting in ascending order. The D means you will sort in descending order. So let's sort this in ascending order. Now, what list did you enter all of that data into? List 1. Now, if you notice, look at your calculator, whether you would have a black and white or a color one. What's going to happen is this. If you hit second and 1, it will be L1, and you don't even need to close a parenthesis. But here's what happens when you go to edit. Take a look. The data is now sorted in ascending order. Now, that's going to make our lives a lot easier when we go to do a few things. All right, any questions on that? Because it's also going to be right in front of you here. Get practice. Practice makes perfect. Sorting data on the calculator and whatnot. Now, I know with assignments and whatnot, large amounts of data, you could make a mistake. And if it happens, don't fret. I'm the king. I like to consider myself like, before we move any further, we see that the lowest price GPS system is $53. Now, we can scroll all the way down, or we could actually scroll up and see that the most expensive GPS system in this case was $440. Yeah. Oh, I dropped my microphone. See? All right, good. So yeah, the most expensive GPS is $440 today. Well, back when I wrote this data. All right, so that's going to be kind of a good lead, and we're going to hold on to that. Now, percentile, this is a big thing. A lot of people don't really know what the concept of percentile is. We're going to see it more when we get into chapter 5 or the third unit or the normal distribution. But for now, we're going to be doing this with raw data. Percentile is simply the number of values below a certain mark, and it's divided by the number of values times 100. Now, what happens here, though, let's go with just the raw concept of percentile. For instance, if a child's height at age 10 is in the 80th percentile, can anyone tell me what that means? That means your child is taller than 80% of their peers. Now, that means they're taller than 80% of their peers, and if they're taller than 80%, they are shorter than what? Correct. How do we get 20? 100%. So, let's say if a child's weight at age 12 is in the top 15%. Now, top 15% is the same point as what percentile? 85th percentile. Of course, you'll see like top 15% or like bottom 15% or whatever. I remember when I went to my first college orientation, they said, all right, those of you that were in the top 20% of your graduating class, stand up. And I didn't. My mom's nudging me. And I was 24th in a class of 100. So I wasn't top 20%. But they were saying, it's so competitive here. But yeah, so top 15%, 85th percentile. Now, we're going to be dealing with percentiles mainly with ogives. Now, we're not going to make ogives, but what we're going to do is we're going to read them. I think ogives are going to be kind of cool. This is an ogive. It looks like ogive, but it's really ogive. So, here are the prices of all the GPS systems. We're going to figure out the percentiles by the following price. So, for the $100 mark, how many are below $100? Well, in the old days, before your graphing calculators, you would have to go in and count that. But we have a calculator that sorted it. So let's take a look at this. And this is the what value? The 8th value. Now, this is the 9th, but that is over $100. So, how many were below $100? There were 8 of them. So, consequently, the percentile is going to be 8 out of how many pieces of data were here? Times 100. So basically, this would be the 16th percentile. So I want you to do the same thing for a $200 GPS unit. All right, so for $200, how many were below $200? Looks to be 31. I didn't say at, we wanted it to be below. So basically, there were 31 below the mark. So 31 out of 50 times 100, what percentile does that put us in? 62nd. Very good. All right, we'll do the $300 mark. Units were below $300. 42. So the percentile is going to be 42 out of 50 times 100. One thing, or the 84th percentile. One thing I do with data like this is I always have it out of like 50 pieces or 100 pieces. It's going to make it easier to calculate percentile. Now, so any questions on this particular topic? Okay, so what I want to do, we're actually going to bypass this next part, and this is what we're going to do. We're going to talk about a cumulative relative frequency called an ogive. Now, we're not going to make ogives, we're going to read ogives. Now, this kind of an ogive sucks because it's just so hard to read because you don't have bars. But basically, the horizontal axis is typically the score that you're measuring, and the vertical axis is the percentile. Now, data can be split into deciles, that's groups of 10%. We're also going to learn quartiles later on. So, for instance, this ogive, this is not an ogive I would ever give you on a test or anything because you'll see why. Now, what test score would represent the 62nd percentile? I'm going to go ahead and tell you what it is here, and this would be 1600. Now, if I were giving you a ogive on a test or something, it would have bars that even Stevie Wonder could see. Like, you'd be able to see it. Like, we'll come right back to this, I promise you. But I don't know why I kind of jibber-jabbered around a little bit here with ogives, but I know yeah, see, this is a much better ogive. See how it's got bars and all that? So, yeah, 62nd percentile is a score of 1600. That means 62% score. This was when the SAT was 3 sections, by the way. But if I'm not mistaken, North Carolina is an ACT state, isn't it? Yeah, see, SATs are more Yankee states, apparently. Below 1600, 38% would score above that mark. Yeah, again, that's when the SAT was 3 parts. Reading, well, yeah, when it was 3 parts. And you cannot, like, you look at someone, you talk to someone about their SAT score, and yes, especially someone who took the SAT more than 10 years ago, it's like apples and oranges. It is so different. Now, so the vet bills at Mount Olive Animal Hospital, so what value would represent the 40th percentile, do you think? $100. Now, what value would represent the top 20% of vet bills? So top 20%, well, what percentile is that? The 80th percentile. So if you look at the 80th percentile, what's that appear to be? Yeah, 175. But we would say or higher. And here's why we would say or higher, because it was the top 20%. When you hear top percentage, you say or higher. Now, if I said bottom 40%, you would say $100 or lower. Very good. But if I asked you straight up for percentile, you would not need to say higher nor lower. But yeah, top percentage is whatever that is or higher. Bottom percentage is whatever that is or lower. So y'all with me on that? All right, now if you're not, please ask. That's yes.
So I understand that, but like, why is that the case?
Okay, so top 20%. So if I'm saying, what is the top 20% of vet bills? Well, that mark was $175. And since it's top 20%, it's got to be $175 or above that. So does that clear it up a little? Okay. Now, bottom 40%, generally, I'm thinking like bottom 10%, bottom 40. I don't know what the heck anyone would want that for, but where would I be in like the bottom 5%? Someone would say, oh, the coolness factor, top 5%, I'm probably in top 5% of geeks. It's okay. Now, again, another way to think of percentile is the percentage below a certain value. So, for instance, the 95th percentile of height means that the height where 95% of the heights are below that, and consequently, what percentage would be above that? 5%. Yeah, I mean, I was a big kid growing up. I mean, I was 9 pounds 11 ounces. So yeah, my mother is 5'7". Yeah, I did not come out naturally. We'll just say that. In fact, the story I heard was they had to push. For that matter, other standardized test scores typically are given in a range of middle 50%. Now, middle 50%, what percentiles will comprise the middle 50%? It's a range. You're probably looking at this data here, but we're just talking general here.
Oh, okay.
That's okay. But let me see here. The 25th to the 75th. That is middle 50%. And so when I ask you a question based on an ogive about middle 50%, you're going to give me the 25th and the 75th percentile values. Boom, that's it. Now, here is something with textbook costs. What textbook cost is approximated by the 40th percentile, and which one is the top 20%? Now, this one's a little better, but I have to make sure. Good. So, middle 50%. What's the difference between 75 and 25? That's why. Approximated by. So yeah, I gotta figure out a better hotkey for this. Don't worry. All right, so here's the question now. What textbook cost is approximated by the 40th percentile? What do you think? Yeah, $140 is what I would probably go with. Now, what textbook cost is the top 20%? What would you go with for that one? Top 20%. $170 or higher. Now, top 20% is represented by what percentile? 80th. Now, how about, so here's what we're going to do. Rather than move on to a different topic, for some reason in my notes, we're going to go to page 13. Now, the ogive that I'm going to give you is going to be a lot better than this one, a little more detailed. In other words, the percentiles will be in increments of 5, but the test scores, I would have like small bars between here. So like this would be a 5, this would be 22, this would be, let's call that 34. I could call this 56, 60, I'll call that 62, I'll call that 64. I'll call this one 66. I'll call this one 68. Yeah, see, not the best thing here, but yeah, 71, 74, and so on. So here's a good question here. Approximately what score will represent the top 10%? Now, top 10%, if I want the top 10%, what percentile am I looking at? 90th. So, in my not so good, see, the one you will have, the test scores will be increments of 2, you'll have bars. You'll see what I mean. But if I want the 90th percentile, which is right up here, that test score looks to be what? Let's call that an 83. So top 10% would be 83 or higher. So approximately what score represents the 40th percentile? Looks to be about a 66. Now, would you need to say higher or lower? No, because that's a direct value. So I want you to figure out the score represents the 65th percentile. What do you say? Yeah, I would go with 74. And how about bottom 15%? 56 or lower. Now, approximately what percentile is represented by a score of 70? Well, okay, good. 70 is right on the mark. So a score of 70 is what percentile? 55, highway 55. Or 55th. And a score of 80. Now, here's a problem. There is no 80 on here. I would not ask that on a test. And rather, I would have said 79 maybe, but we could say 82nd or 83rd. Now, approximately what test score represents the top 35%? Not quite. Top 35%, 74 or higher. Yes?
I'm confused on why E is 50.
Okay.
70.
Look at a test score of 70.
Oh, okay. Never mind.
Now, part F, I would not ask you one like that on a test because, yeah, I don't want to have like any kind of ambiguities for test questions. try to confuse you. By the way, if you go to Moodle on Unit 1, I post all my old tests and reviews because I write a new test. I basically just replace numbers. Come on, it's easy. But top 35% and 65th percentile, one thing I like about these ogive questions is C and G, I get the same value. See, I'm asking the same question kind of two different ways. Now, middle 50%. Now, what's half of 50? 25. So if I want middle 50%, I can go 25 below and 25 above. So the 25th percentile looks to be about 62, and the 75th percentile looks to be about, I would call that 78. Trust me, when you go to Moodle and see the old tests and the keys, you'll see that, yeah, I post all my old stuff. I make new ones. It's kind of my hidden talent. I can knock out it's actually real easy for me. All right, last thing I want to do here, approximately what scores represent your middle 90%? Well, here's a good question. Half of 90 is what? So we're going to go 45% below and then to 45% above. So basically, now the answer I'm not looking for, 5th to the 95th percentile, but here's the question. What is the distance between 5 and 95? Middle 90%. See? Now, the 5th percentile looks to be what? 22. And the 95th percentile looks to be 95. Wow. So yeah, 22 to 95. Now, yeah, there's plenty more practice for this on Moodle when you go to look at that. But these ogives, I think, are going to be very good. Back into histograms. Now, the good thing is we're going to use the data that we have and figure out, and so in this case, given the actual class width, so what's going to happen here is you'll be given the class width and also be given information as to where to begin. So, in other words, what we're going to do here for this data, we are going to start with $0 and go with a class width of $100. Now, you're probably thinking, what's all this stuff here? Because if you notice, 0 to 99, that is not $100. This class width of $100, the purpose of a class width of $100, we would be adding $100 to every lower limit, or adding $100 to every upper limit. Now, there's a slight difference between lower and upper limit and lower and upper class boundaries. The purpose of, if you notice, to go from the lower limit to the lower class boundaries, you're subtracting a half, or 0.5. To go from the upper limit to the upper class boundary, you're adding 0.5. But why do we do the boundaries? Well, here's why. After we figure out the frequencies, here's what a lot of students would do. Why boundaries? Because here's what happens. They would go 0 to 99, but then 100 to 199. So do you see the problem with that? So this is going to be kind of an explanation as to why we're going to use boundaries. So basically, yeah, like, you know, the no smoking sign? Yeah, it's that. But what we're going to do here now is we're going to put the class boundaries, negative 0.5, and then the next boundary point was what? 99.5, good. And then the next one after. So we're adding increments of what? 100, which is still our class width. But here's the thing. There's going to be no gaps in this. Now, the vertical axis for this will be whatever the frequencies are. But here's the thing. We're going to kind of hold off for a few minutes. Yeah, frequency, keep in mind, frequency is the count or how many occurs. Now, because of my piss poor art skills, the bars should be equally the same, but it's probably not because, again, my terrible art skills. But forget about that. So this is where it's going to get good for us. Frequency. So what you would have to do, if you didn't put this data on a calculator, you would actually have to look at all 50 pieces of data and count how many were between 0 and 99, 100 and 199, and so on. But thank you, calculator. Because here's what we're going to do. Obviously, between 0 and 99, I had how many? I had 8. Now, we're going to worry about relative and cumulative and all that in a few minutes. Now, if I wanted how many between 100 and 199, well, that's easy. I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, lot, 23, 23. Now, here's a good question for you. So the first frequency was 8. Now, cumulative frequency. Here's a good question. How many GPS systems were below $0? There were none. So the cumulative frequency is going to match the frequency for the first group. Now, in the $100 to $199 group, there were 23 of them. But how many were there before? What is 8 and 23? 31. Now, here's something really cool. Look at that value here. 31. This is kind of a backdoor method. But I'm also going to show you how you can use the calculator to do a frequency chart. You are going to love it. Well, I hope. So if I wanted to count between $200 and $299 for a GPS, I count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I counted 11. So what would my next cumulative frequency be? But here's the thing. Look at the calculator. That last value in this range was, there were 42 of them. So what's 42 minus 31? You could have gotten it that way. So there's so many nifty ways you can do this. Now, in the $300 range, we go 1, 2, 3, 4, 5, 6, There were 6 of those. And in the 400 to 499 range, we had how many? 400 to 499? We had 2. Now, this final cumulative frequency of 50, how many pieces of data were there? There were 50 pieces of data. So, and I'll be honest, this is actually the first class that I've realized that, yeah, we can get the cumulative frequency and then get the frequency that way, but we're also going to see how this can be done straight up on the calculator. So, now relative frequency, I didn't quite explain relative frequency as much, but basically relative frequency is the percentage of data. How many pieces of data did we have in this? 50. So basically we take all of our frequencies and divide them by 50, which would be 0.16 or 16%. This would be 46%, 22%, 12%, and 4%. If you gave them to me as decimals, that's perfectly fine. Now, cumulative relative frequency. Relative frequency is basically percentage. So, if we did cumulative relative frequency, let's see, that's 8 over 50, that's still going to be 16%. Now, 31 out of 50 is what? 62%. But what is 16 plus 46? Ding, ding, ding. 42 out of 50 is, or what is 62 plus 22? Boom! 96% and then 100%. If we were making our own ogives, which we are not, we would use cumulative relative frequencies, but we are not. Instead, the ogives that we'll use will be read. I mean, we will read them and answer questions based off of them, but we're going to go ahead and make a frequency distribution. So the highest frequency was 23. So if we go to the next page, we could probably safely put these frequencies in increments of what? Let's make them in terms of 5. Yeah, increments of 5, 15, 20, and then 25. So this is where you'll make the bar chart or the histogram. Now, you're probably thinking, you know, how good does this have to be? I'm not going to expect you to be some kind of art major here, but in that first group, how many did we have? We had 8, so I'm going to draw a bar that's about 8 high, and maybe that's closer to 9, but I'm not going to pull out a magnifying glass and say, oh, this is too much, or whatever. So now the next group between 99.5 and 199.5, or $100 to $199, how many were there? 23. How many were in the next one? 11. How about the one after? 6, and then the last one. Okay. Now, so here's the thing. I'm also going to point out here, pages 11 and 12 show how to do this, how to make the histogram on the calculator. But here's the thing. The example that's shown in the notes there, it's different from the example we're working on here. Like they're using all different data, but we're not going to. We're going to use the same data that we had. But, so if you look here at pages 11 and 12, namely, yeah, class width, well, we already know what our class width is going to be. So we're not going to use this data here. But one thing you'll need to do now, especially if you're using one of my calculators, you go to y equals and make sure there's nothing here. Make sure all that is cleared out, because I have 3 different classes that I teach, and chances are someone is using one of the yellow or white calculators to do this. Now, of course, there's actually a separate video on Moodle. Let me point out something else to you here. So we go to the course Moodle page, and under unit number 1, which is what we're on, Descriptive Statistics, histograms video, there's a separate video that I made that you can reference on how to do histograms, but I'm going to walk you through anyway. So anyway, back to the business here. We want to make sure all this is cleared out. Number 1, determine the class width. Now, what was our class width that we had before that I had given you for this particular question? What was it? 100. Now, enter the data and then clear out any equations, and here's what we're going to do. We're going to go ahead and do our plot now, so you'd hit second and stat plot. And you notice you have options. And we're going to turn this plot on. Now, you might get a dimension mismatch somewhere. You might have to turn off other plots. But in this case, we have this one. Now, there are 6 types of plots. The third one is what I'm focused on. Yes. Oh, thank you. I don't know why it does that. Well, it picks me up anyway. All right, so the third plot is the histogram. That's what we wanted. Now, the X list is L1, which is what we had now, and frequency is 1. Don't touch that. Now, so here's the thing. When we go to graph that, we see something that's rather screwed up. So don't freak out. Because here's what's going to happen. So if you look at particularly step 12, we are going to go to the window value. Now, in fact, here's what I'm going to do. I'm actually going to do this, hopefully. Yeah, perfect. So, the X-min, what was the smallest class boundary? Not limit, but the smallest class boundary. Negative 0.5. Negative 0.5. Now, what was the largest class boundary? Oh, yes. That screen hit the window button. The window button at the top of, right above the mode one. No problem. Now, the highest class boundary, yes.
How do you select? So mine's just blinking, and I hit enter.
Oh no, you got to, number 1, turn that on, and then you'd hit graph. Well, plus you got to make sure you want list 1. Yeah, make sure that that's list 1.
Okay.
But you won't see anything. And you'll see why in a few minutes. Don't worry. Anyway, now, our largest class boundary was 499.5. Now, what was our class width? 100. Now, here's what I'm going to do. I'm going to copy and paste this into the notes for your convenience. So basically, this first one was, if I can get this to work, too much. Close enough. Yeah. So this X scale is your class width. And the boundaries. Now, we're going to change that Y min to 0. The Y deals with frequencies. Because here's what happens. We have an X max of 10. There's the bars. Now, but even though it's out of view, hit that trace button on here. Hit that trace button. And look at N. What does that say? 8. There were 8 pieces of data that were in that group. Now, the next one, you can hit this one to scroll over, and how many were in that next one? 23. See, there's your frequencies that way. Now, another thing we can do here is if we go to Window, let's change that Y max to 25. And now, so for the Y max, you might have to apply what's known as the Goldilocks principle. It's too high, too low, or just right. Now, make sure, so here's the thing. When you go to this, plot 1, you hit enter, it doesn't do anything. You have to actually hit graph. Make sure the X list is the data that you entered. So that's what you're looking for in that sense. So that's going to be a big asset to us. Now, we're going to continue on with this data. And we're going to, now we're actually going to go to page 7. Go to the bottom of page 7. There's a second way to make a histogram. And this second method of making a histogram is, I'm going to say, use a number of classes. So here's the thing. The smallest value, for the class, smallest class starts with the minimum value. In this case. So, here's the thing. We're going to find the class width. And for the class width, this is the big, big, big thing. We determine the range, which is max minus the min, and divide it by how many classes there were. But we always round up, and here's what I mean. Let's say, for an example, you got a class width was 12.1. You round that to 13. You always round up. Let me ask you that again. Which way do you always round? Up. Do not ever round down on this. Even if it's like 12.02, you would round up and it would need to be 13. Now, if it were 12.8, you would still round that to 13. So, we're going to use the same data that we just used. And what we're going to do with that is we are going to figure out the class width. Now, how many classes does it say on the next page? 8. Now, I'm going to skip midpoint. We're not going to worry about midpoint. In fact, I'm going to extend class boundaries into this column for my purpose. Now, what is the minimum price? $53 big ones. What is the maximum price? $440. So we need to figure out the class width, or CW. That is 440 minus 53. And how many classes were there? 8. So you would do 440 minus 53 and divide it by 8, just like this. 440 minus 53 and divide it by 8, and I get a class width of 434. Okay, did I do something wrong here? Parentheses. Watch this. Now, I would want to do 440 minus 53 and then divide it by 8, and I get 48.375. But do I round up or down? So my class width will be 49. If you rounded down, you are going to run out of space. And you would have to make a 9th class, but that would make the problem wrong because you don't want to do it that way. So, our minimum was $53. Now, that's where we're going to start it. In this case, we would always start with the minimum. Now, what is 53 plus 49? $102. Now, you are basically, so we have the lower class bounds just by adding $49. This would be 151. Yeah. Now, before we figure out the next one, this would go from 53 to what? 101. And this would go 102 to 150. Look at it this way, folks. 101 plus 49. 150. Now, for the boundaries, this is where it's important. 52.5 to what? We're not subtracting. This is the range of values.
So wouldn't it be 52.5?
Not 100.
Oh, 199.
101.5. Because
Why is the 53 rounded down but not the 100?
you subtract 0.5 from the lower and add 0.5 to the upper. Now for the next one, you would subtract subtract 0.5 from this, but it matches up with the fact that this was 101.5 and then 150.5. So we want to figure out our class bounds before anything else. So yeah, 200, 249, 298 plus 49. And yeah, I have to use a calculator sometimes. 347, that sounds right. Yeah. Don't be afraid to use a calculator for something like this. And then 49, that plus 49 should be 396. So I could add 49s to that, or basically one less. So I'm not subtracting. These are ranges. Now, a lot of people might get flustered and see, wait, 444? But wait a second. What was the maximum value? 440. This is not going to match the maximum value. So don't freak out on that. It may go above the max. Now, I've been teaching this class for several years. And students will say, but Mr. Jarrett, this ended at like 432 or whatever. What do I do? And I'll say, well, what did you give me for the class width? And chances are they would have said 48. That's why you round up. So, here's what we're going to do. Let's figure out our class bounds. So yeah, 150.5 to 199.5. But see, if you notice, the boundaries just pick up where the other one left off, or the last one left off. Yes? Okay. Let me write this out real quick and I'll gladly explain. See, lost my train of thought there, but now it's back. So, basically, to go from this to this, you subtract a half. To go from that to that, you would add a half. So what happens here, if you go by actual raw data, it goes from 53 to 101, then it goes to 102. The purpose of the boundaries, that's what we're going to plot on our histogram. But here is another $1 million question. Here's our next $1 million question. This 52.5, when we go to do this in the calculator, we can put that in as our what on the window value? X min, very good. And this 444.5 can go in as our X max. So, here's what happens. 52.5 and 444.5. But what do we want to put in for our scale? 49. Now, the Y-min should always be 0. Now, for the Y-max, so if you've entered this and you find that the graph might be a little too small if you're OCD like me, maybe I'll make that 20 just to make that a little bit more readable. But for the Y-min and max, you're thinking Goldilocks. It's too big, it's too small, or too hot, it's too cold, and it's just right. So, with that in mind, here's what happens next. You go to your histogram and watch this. Hit the trace button. Nope. Go back to graph. I hit the trace button. How many were in that first group? There were 8. Now, the fact that there were 8 in our previous question just happens to be an absolute coincidence. Now, how many are in the next group? 15. And we get 8 again. And then, and if you notice, 199.5 to 248.5, and look at the boundary. See? It's awesome. So that's 5. And how many were in the next one? I think that will be 6, 5. And don't freak out if you see a count of 0. Never freak out on that. 1, and then I think this is a 3. No, that's a 2. Now, can make the cumulative frequency. What is the cumulative frequency going to start at? It's going to start at 8. And then the one immediately following that will be 8 and 15 is 23. And then we add what? We add 8 or 18? 8. Oh, don't write the 8. There you go, 31, 36, 42, 47, 48, and then 50. Now, absolutely. Okay, I can probably tell you why that is in just a second. Oh, because you didn't have the right plot on.
Oh, okay.
You wanted histogram.
Okay, thank you.
So to get to the histogram, hit second and... Now, let me point out something here. Let me just point out a few things that I've been seeing people make mistakes on. And here's the thing, do not feel bad because it happens. You go to y equals, some people have left this on there. Make sure everything is clear. Make sure all that crud is cleared. Y equals. Yes, y equals will get you right to that. Here's what I'm going to do. Basically, I'm going to be semi-lazy and do this. And do the histogram this way. Why? Because I can. Well, it's probably a heck of a lot better than I could ever draw. 52.5. And then, yeah, 101.5. 150.5 and so on. But yeah, pretty easy, I think. So there's that, and you can do this is what 8, and the one above that was 15. Yeah, see that's a lot better than I could have ever drawn. And I shake a little bit when I try to draw with precision. It's just the way I'm built. Maybe I'm too hepped up. I don't know. But I'll be honest, I love doing this. I could go another 2 hours of class if I could, but I don't think you would like that. So that's histograms in a nutshell. Now, we can do our own histogram. We can do a histogram based, off of other data here. And let's do that. Now, But here is a good idea here. We're going to work with 8 classes here. Now, instead of deleting the data, put this into list 2. So yeah, I want to enter textbook prices, even though, as I understand it, basically every textbook that you buy today is all the same price. See, when I was in college, that was not the case.
Well, with our school it is because they just started.
Entered all of my data. So yeah. So the first thing I'll do with this data is I'm going to go ahead and sort it. And here's why. Now, the list that I used was list number 2. Now, this would enable me to find the minimum and the maximum much quicker. So when I go to Stat and Edit, I see that my minimum value is $77 and my maximum is $270. So, with that in mind, let's figure out the class width. 270 minus 77 over how many classes? 8. Now, here's a cool thing. If you hit alpha and y equals, whether you have a black and white or a color calculator, you'll see this. And it's 270 minus 73. It was 77. Oh, that could have been brutal. Over 8. Now, problem is it gives me a fraction. But if I multiplied it by 1.0, I get 24.125. Therefore, my class width is going to be what? 25. Now, in this case, the minimum is 77. So the first boundary is 76.5. And we're going to be adding increments of what? 25. So that's 102. Yeah, don't worry about midpoint. In fact, I've been meaning to take midpoint off of there. A good course of action for this is to find all your lower class bounds right off the bat. So yeah, 127, 152, 177, 202, 227, and then 252, 126, 151, 176, 201, 226, 251, and 276. Now, here's the next thought. Some people will say, Mr. Jarrett, but the max is 270. Well, yeah, but 276, that's where it's going to end. Now, here is something really good. 276.5 is going to be my boundary, my maximum. So here's what I'm going to do now. I am going to go to stat plot, and instead of L1, I'm going to use now L2. And I'm going to go to window, 76.5, and 276.5, and then 25. Now, and there we have it. So, here's what's going to happen. We're going to get the frequencies on Monday because we're just going to be plumb out of time. But on Monday, we're also going to do, I'm going to kind of brush through stem and leaf plots, I'm going to get into some calculations of things. So you borrowed a calculator from me, like a gray one, get some batteries, but I actually have 10 more yellow and white calculators in my office. All right, we left off talking about various textbooks in a bookstore here. And what we did here was, I've entered the data here on this TI-84 emulator here. And what we've done here is we figured out the class boundaries and whatnot. So when we do that, we kind of got our histogram this way, but we didn't actually fill in the frequencies. So since I entered this into list number 1, I can go to plot 1 by hitting second and y equals. So, and I want to go turn that to a histogram. Now, I have the data in list 1. I had it in list 2 on my other emulator, but I just got this one. So we're going to use list number 1. Now, we go to the window value, and since the smallest class boundary was 76.5, that's going to be the X-min. And the largest class boundary was 276.5. And our scale is going to be 25. Now, the Y-min should always be a 0. Now, the X-max, maybe I'll try 15. Now, here's the thing. Kind of have the luxury of this with Texas Instruments here. But remember, this is your min boundary. This is your max boundary. And 25 is your class width. Now keep in mind, these calculators are also used by my 171 and 172 students, so you might find some foreign material on there. So like in Y1 or whatever, you might have to go clear that out. That's okay. Now, when I go to graph this, I see something like this. Now, the nice thing is I can hit trace, and I see I have 10 in that first group. Frequency, keep in mind again, is the count or how many. So we have 10 there. In the second group, we have 5. See, this beats having to actually physically count everything out, in my opinion. You have 7 here, and then we have 2 sets of 6, 2 6s. Then we have a 9, 5, and a 2. So, that's what we have for all this data here. Now, the nice thing we can do here is we can easily figure out our relative frequencies. Now, what is the grand total for the number of pieces of data in this particular set? 50. So literally, you could just divide all these numbers by 50. So 10 out of 50, well, that would be 20%, or 0.2. This is 10%, 14%. You have a 12% here, and a 12% here, 18%, 10%, and then 4%. Now, you could give me decimals for those if you want as well, but percentages are just as well. All right, so cumulative frequency, the number below 77 was just none, so the first cumulative frequency is just going to flat out match this frequency, and that's going to be a 10. So the next cumulative frequency down the line will be what? You have your notes with you? Oh, okay. Now you can also watch the videos. So what's the next cumulative frequency going to be? 15, because 10 and 5 is 15. 15 and 7 is 22. Then 28, 34, 43, 48, and lastly, 50. And that last cumulative frequency should match the grand total. So finding the cumulative frequency, in a way, is checking our counts out. Now, of course, let me go ahead and tell you, if I give you a problem, if I give you a histogram on a test, I am going to order the data for you. Make it a little bit easier. So you can count it by hand, or you can do what I like to do and use a calculator. And then cumulative relative frequency. Basically, all you got to do there is divide the cumulative frequencies by 50. So in this case, we get 20%, or add the relative frequencies. 20 and 10 is 30%. 30 and 14 is 44, or 22 out of 50 is 44%. And this last one should be 100%, or 1. And then you just draw the histogram, and that's it. Now, if as part of the first case study that you'll do, you'll be expected to give me a histogram as part of it. Now, that video, there's a video on Unit 1 that shows you not only how to do histograms on the calculator, but it will also show you how to use StatCrunch. So that video you can use, and it should be right there. And I think that video I put on YouTube, which is fine. So there's that. All right, any other questions about histograms? Now, we're going to brush over a couple of other graph types, and then we'll get to pie charts. Pie charts, I think, will be a lot easier. So, then you can draw the histogram. Let's not worry about those questions here, but we're going to go ahead and jump on down to, what's it, page 14. Now, stem and leaf plots, I'm not going to give you a stem and leaf plot on a test. Here's the thing, you'll see that on your MyLab, but yeah, if I were to put every single thing on the test that I gave you, your test would be much longer. Now, stem and leaf plots are relatively easy. Each number is separated into a stem and a leaf. The leaves are the rightmost digit, and the stems are everything but that. For example, if this is our data here, like 21, 25, the stems are all single digits. The stems are 2, 3, and 4. And all you have to do is literally just, for the MyLab questions, you would enter the leaves. You should be able to just enter the leaves on that one. So, here's an example here. The data go from a low of 78 to a high of 159. So, this is known as the key for your stem and leaf plot, 78 and 159. So in this case, the stem is a 15. So you can make a stem and leaf plot with ordered or unordered. It's easier to do it with ordered. But if you notice, whether it's ordered or unordered, it takes on the same exact shape. And again, I'm not going to put a stem and leaf plot on your test. You'll see them on my lab, and it's the same thing with dot plots. Again, I know some people have done stem and leaf plots back in middle school, but I also realize, especially those of you that are just out of high school, middle school was COVID years. So dot plot is basically just another form of a stem and leaf plot. If we have data here, we just put dots right above. And if there's a repeat like 225s, you would see there's 2 dots. So nothing really fancy about dot plots, but here they are. And just another couple examples of dot plots and stem and leaf plots. Now, I might give you a stem and leaf plot, and that's where the data will be. So if you read, and I'll give you the key here, this is what, stem and leaf plot. You can enter the individual values if you want on a calculator. Now, a pie chart is going to be where we divide a circle into sectors that represent categories. And the area of each sector is proportional to the frequency of each category. For instance, this is what one person's free time that's not spent by sleeping is doing. Now, so here's kind of a guided example of a pie chart. The number of earned degrees conferred in the year 2007. So for instance, 728,000 associate's degrees were conferred. Now, what degree do you earn from this school? You earn an associate's. Odds are you'll transfer to somewhere and get your bachelor's. And then you'll get a master's. Now, first professional and doctoral. First professional can be construed in many ways. A lot of people like to call themselves doctorates, like even if they haven't done their dissertation or whatever. To me, no dissertation, you're not a doctorate. I'm sorry. I did a thesis for a master's. That's as far as I went. So basically, we find the relative frequency. So we got to add up the grand total. In this case, it's 3,007. Now, I'm not a big fan of this example because this is an oddball number, 3,007. The example that we're going to have is going to be a nice terminating decimal. You'll see what I mean by that. So what happens here is we find the relative frequency. Now, we notice that bachelor's is going to have the highest slice of the pie. Now, to find the central angle, what you simply do is you multiply the relative frequency by 360 degrees. Yes?
You don't even turn the numbers into thousands before you
We're going to round. So here's the thing. This example is not the best because these are rounded. In the example we do, the relative frequencies are all going to round to 4 decimal places, which is thousands. Or 10,000s really. But, yeah, so this is a more basic example, so to speak, here. So the other thing is that angles might not add precisely to 360. It might add to 359 or 361. Don't freak out. It's because of rounding. We are not going to round. We're going to round angles to the nearest whole number. We're not going to worry about rounding angles to like hundreds. because we're not going to be that precise. And then when we draw our little pie chart here, we see that for this pie chart, almost one half of the degrees conferred were bachelor's degrees. So, yeah, first professional can be construed a lot of ways. Like, first professional can also be like a nurse practitioner. I was actually kind of shocked when I moved here and I needed to see a doctor about some things, and I ended up getting a nurse practitioner, and she was able to prescribe. I was like, whoa, you can prescribe? I thought you had to be like a doctor, like an MD. Like, they can't prescribe certain things though. Like there's limits to what they can do. All right, so we're going to make our own little pie chart here. So these are car brands registered to UNC students. Now, the first thing you need to do is find out the grand total. Now, the grand total should be a nice, clean, easy number. And it's going to be 5,000, yes. Now, so this little chart here, this is going to be 80% of the score. Doing all this. The pie chart, and for some stupid reason on my part, I did not put a blank pie chart on there, but I will next time. For some reason, I just forgot. Yes? Everything added up. 5,000. So, Hondas, now you don't have to write all these out each and every time, but 944 out of 5,000, it'll be a nice terminating decimal. See, this is why I prefer something like this, 0.1888, or 18.88%. So, the angle for that, we literally take this whole decimal, multiply it by 360 degrees, and let's just round it to the nearest whole number. And we're going to round that to 68 degrees. So you'll need to find the angle for all of these vehicle brands, Honda, Toyota, and I say parent brand because, like, what does Honda own? Acura, Toyota. Yeah. All right, so for Toyota, the relative frequency should be 0.2244 or 22.44%. Do you have to write both of these down that way? No. And Toyota will be 81 degrees. So then you have GM, which is 0.0888, and that'll be 32 degrees. Chrysler Fiat, 0.1048, and this would be 38 degrees. I had a PT Cruiser for 15 years. Can't complain too much about it, except I had to have the engine rebuilt like twice. But it was I ended up buying a lifetime warranty. But lifetime doesn't mean lifetime. It means whatever they deem to be good is a lifetime. And I could tell the transmission on my Cruiser was failing. And they would have cut me Blue Book if I hadn't used the warranty, but I had used the warranty. So basically, you know, it was time to retire. And Hyundai and Kia. And let's see here, 19 and then 42 degrees. Now, if you add up all the angles, 9, 11. Yeah, it may or may not add to 360. So 68 degrees. So I could start here. See, this is going to be a terrible looking pie chart. So 68 degrees for Honda. I like Hondas. My wife has a CRV, got 7 years old, 100,000 miles on it. Doesn't look like it's going to crap out anytime soon. So there's that. Now, 81 degrees. So here's the thing. You can't start from the same place, but what is 68 plus 81? So in a way, we're going to do cumulative angle. 68 and 81, I believe, is 149. Let me double check that because I'm getting old. Not really. But yeah, 149. So 149 degrees, let's see, that would be 180. Yeah. And again, I'm not going to be like that state trooper where I'm going to pull out a tape measure and measure how precise you are. You know, 81 degrees for the Toyota. And then GM. So yeah, back when I was a kid, GM was the best. Now they suck. Sorry. Shouldn't be that blunt here. 149 plus, is it 32? 179, 181. So and then Chrysler Fiat, 181 plus 38, that would be 211, 219. Let's see, and that's 38 degrees. Yeah. Notice that this pie chart sucks. Like, yeah, don't. The one that's on your lab assignment is going to look so much better because it's marked here. But now, does that mean I'm going to go through every one of yours with a magnifying glass? Look like that? No. Number one, I don't have time. You know, I look for the general shape. And then Nissan, 219 plus 48. Let's see, 259, 267, probably a little off. And then Ford, 299. And just do Volkswagen and Hyundai and Kia. And right there, yep. So that's how we do a pie chart. Any questions on that? And again, that chart up here with all the numbers and such, that's going to be like 80 to 90% of the question. You know, I'm not going to go through with a fine-tooth comb with your pie charts. You know, I just don't have, you know, it's not middle school here. So that's how that's going to work. So pie chart is pretty much straightforward. Nothing fancy. Believe it or not, you can do a pie chart on StatCrunch as well. Now, a pair 2 chart is basically just another vertical bar graph where it's in order. I'm not going to give you a pair 2 chart on a test or anything, but basically it just puts the bars in order of decreasing height. Now, one thing I always get a kick out of this, who in here has worked retail before? I always get a kick out of this one. In a recent year, retail has lost $36.5 billion in inventory shrinkage. And inventory shrinkage is the loss of inventory through breakage, pilferage, shoplifting, and so on. So if you look at this, if someone actually posted this article in the Washington Post, and someone reading that would see, oh my God, look at that. Employee theft is so rampant. Boy, those Walmart employees are real thieving dirtbags. Here's the thing. Those of you that have worked retail can answer this question. Why is employee theft more than shoplifting? Well, more access to reporting. You can document employee theft much easier than you can shoplifting. A lot of shoplifting goes unreported today. I mean, it's...
Most of the time, and even if we notice someone shoplifting, there's nothing we can do about it legally. We literally have to watch them walk out the store. We can report it later, but most of the time, nothing happens.
And I'll tell you, go to any major city, and there are places that won't even... All right, paired data sets. This is just kind of an introduction. We're not going to be doing scatter plots until... It'll actually be after Thanksgiving when we do scatter plots. But basically, if we had paired data like this, we would simply graph it. You know, you have a horizontal and a vertical component, or an X and a Y value for each, and the data is paired. So this is just kind of a little introduction, so to speak, to a scatter plot. So scatter plots can deal with bivariate or XY variables. Also time series. Like on the next page would be a time series where the number of subscribers by the year. So there's that. So again, I don't even think I put anything on with scatter plots on your MyLab, but just wanted to kind of introduce those to you. All right, now we're going to be at page 22, where we're going to find mean, median, and mode, as well as weighted means. Now, mean, median, and mode are very simple. Mean is literally the average of a set of data. Median is the one that's in the middle, and the mode occurs most often. Now, if you look at, like on MyLab, especially if you've done questions pertaining to mean, you might see this funny looking symbol. This is known as a sigma, and I know I heard 8th graders using that term. He's sigma or whatever. Yeah, I don't even know what they mean by that.
I don't think they know what they mean by that.
You know what? I think you're absolutely right. I don't think they know what they mean by that. But when you see a sigma in this class, you add the data. And X is the variable used to represent individual data values. There can be subscripts with those as well. Little n represents the number of data values in a sample. Big N will represent the number of data values in a population. Now, the mean is not going to be calculated any differently. But the difference between sample and population is going to ring true whenever we literally are doing confidence intervals and hypothesis tests. So we'll have that. Now, the mean of a sample represented by X bar. Now, I'm also going to show you how to get to that on the calculator. It's actually going to be real easy to do. Basically, this really just breaks it down way too much into a lot of terminology. But we can find a population mean, which looks like a U, but it's actually pronounced mu. And it's literally the sum of all the data divided by the population size. I gotta get my energy back. So we'll be using our sample mean X bar as an estimator of the population mean mu. That's what's going to happen in this course. Now, sample means drawn from the same population tend to vary less than other measures, and it takes every data value into account. However, a disadvantage is it is sensitive to every data value. One extremity can affect it dramatically. So, here's a guided example. Now, I'm going to show you how to do this on the calculator. Now, I think in the notes, you should have them here. Let me see where I have them. I know this is in here somewhere. I swear I put them in here. They've got to be in here some. Okay, so of course, how to enter data and all that. That would be on page 38 in these notes, which seems like a long way off, but I'm going to show you how to do this with the calculator. So what I'm going to do here is I'm going to go into a list, and I can get rid of list 1, can clear that out, and I'm going to enter those 7 pieces of data.
How did you say to clear it out again?
All right, I'll show you that in about 30 seconds. And then 397. So if you want to clear out data, you highlight the top and hit clear and then enter. You highlight whatever it is and you hit clear. Do not hit delete. If you do, you can go back and use what's called the setup editor, and they'll tell you how to do that. And the notes in the earlier calculator instructions for histograms and whatnot will tell you how to do it that way. Now, if we added up all of this data, here's the thing. Now, the calculator is going to do that for us. So we go to 1var stat, and the list in this case is L1. The frequency, we'll leave that blank. And why is that not? Oh, there we go. See, this is what I love about the calculator. So I go to calculate this, and here's the thing. If you added up all 7 of those pieces of data, this sigma x is literally the sum of $3,695. The one above that is the sample mean, or the mean. If you took $3,695 and divided it by 7, you would get precisely whatever that X bar value is. So the mean ticket price is literally $527.86. I'll tell you, who here has flown, I should say, anytime after 9/11? I would almost guess that very few of you might have actually have flown before 9/11. Yeah, a lot of you might not have even been alive. But my God, you have to go through so much grief to fly today. Now, back before that, I never flew before 9/11, but like anybody, long story short, they built a new airport terminal and they built it as like a regional shopping mall in Pittsburgh for that area. And the airport terminal doubled as that. It was actually kind of cool. But 9/11 basically killed that. Yeah. All right. Yeah. Now, if we want to find the median, that's very easy to do. Simply, it's your middle value. And believe it or not, the calculator can do that. So if we found the median, we have to order it. Now, are we going to have to do that? No. Because here's why. The calculator is going to do that for us. In fact, if you have one var stat saved up, or if it's not, you can just go through one var stat a second time, but scroll down. Look at that. Now, the Q1 and Q3 stuff like that, we're going to be hitting that today. Quartiles, that's pretty easy stuff. All right, so that's how you find the median. I used to push finding everything by hand, but now I kind of don't do that anymore for various reasons. Now, let's say the flight priced at 432 big ones is not available anymore. So here's the thing. The median, and this is why I do like to go over this. Some would say, oh, but the median, that median of $412, that's not even in the data. What happens is, if there is an even number of entries, like in this case, what has to happen is you literally take the mean of the middle two. Now, you can do that by hand, or we can go to Stat and Edit, and we can go and remove this $432 flight. Just highlight it, hit delete, and quit. We'll do another one var stat, and let's see if the median is there, and sure enough, there it is, $412. All right. But the reason I kind of go through this by hand is simple. $412, you might say, wait, that's not even on the data set. And it could be the same thing with quartiles, which we'll get to a little bit later today. Now, last thing is the mode. The mode is what occurs the most. Mode most, mo. So basically the mode for this is going to be $397 because it occurs more than the others. Now you can have data that are bimodal or multimodal. You know, we'll talk about that kind of stuff a little bit later. So the mean can be greatly affected by outliers. Now, enter all of this data into your calculator, and I want you to find the mean, the median. Now, the mode, your calculator will not do. Casio does it, though. But we'll go over this. So the mode for this set of data appears to be what? 20. Now, here's the thing. I have this in list 1, so when I go to stat and one var, number 1, always leave the frequency list empty. But in this case, I have that into list 1, so you might have entered it into list 2. Now, if you notice, above the 1, 2, 3, 4, 5, and 6 are L1, L2, L3, L4, L5, and L6. So you can look at it from that perspective as well. But what happens here is we get a mean of 23.75. We get a median of 21.5. Now, why do you think the mean is somewhat noticeably higher than the median? That 65-year-old would be a possible outlier. And we're going to talk about outliers a little bit later today, hopefully. We'll probably hit outliers. But for now, we're going to hit weighted means. Now, the purpose of weighted means are mainly 2 reasons. Number 1, you can actually use weighted means to figure out your grade in a course. Now, basically, when I tell people to make a formula sheet or whatever, some of them will just blindly write formulas and hope for the best. Basically, this is a weighted mean where you multiply the score by the weight and then you divide by the total weight. Now, in this case, the total weight is 1 or 100%. So you really don't have to add or divide anything here. But I'm going to show you something a little bit interesting here in a few moments. Now, so basically your test mean was an 86, midterm was a 96, your final exam was an 82, computer lab was a 98, and homework was a 100. You literally just multiply the score by the weight and add those together. And in this case, it's going to add up to 88.6. The grand total of weight was 100% or 1. Now, I'm going to throw in a bit of a little curveball here. Let's say we eliminate the final exam. Now, if we eliminated the final exam, which let me be realistic, we're never eliminating the final exam. The final exam is going to happen. But here's the thing. You add up X times W without the final exam. So when we do that, we basically add everything but the final, 43 plus 14.4 plus 9.8 plus 5. And that's going to be 72.2. Now, another way you could have done that is if you had taken 88.6 and subtracted the 14.4. Now, no, 16.4. Duh. That's a dumb moment on me. See, I can make a mistake too. Now, here's the big question. What is the total weight without the final? Yes, that's right. And here's the thing. This is how your grade is calculated in Moodle. See, here's the thing. Your final exam is 22% of the grade. Well, you can have exam, written labs, and everything, but only 78% of the grade will be calculatable after the first test. Just the way it's going to work. So now you take the grade, 72.2, and divide it by 0.80. And let's see, would that change things? 90.25. See, that final exam brought you down. So here's the thing. The final exam should not bring you down in this class because what did I say the final exam was going to be on day one? And not only that, I'm going to tell you what all the questions are going to be without the numbers. So you'll know what to expect on that final. Now, mean of weighted or group data, I don't know why I keep forgetting to remove that, but forget it. So I want you to do this. I want you to figure out, and I know it's not a whole lot of room here, lab, homework, quizzes, midterm, and final. So you'll figure out the weight, 15%, 15%, 20. Now, in the case of a grade problem, all the weights should add up to 100%. So you get 87 on the labs, 98 on the homework, 81 on the quizzes, 68 on the midterm, and a 93 on the final. I want you to figure out that final grade. And it's easy. You multiply the weights by the score and just simply add them together. All right, so basically 15% of 87, we'll call that the component. And we don't need to round to a near decimal place or anything. 13.05. 15% of 98, that's going to be 14.7. 20% of 81, then you take 20% of 68 and 30% of 93. That'll be a 16.2. 20% of 68, 13.6, and then 30% of 93, 27.9, and then you add them all up together. And let's see what we get here. 13.05 plus 14.7 plus 16.2 plus 13.6 and then 27.9. That's an 85.45. Now, on a 10-point scale, an 85.45 would be a what? That would be a B. Now, here's the thing. Something probably harmed your grade. And what would that have been? The midterm, namely. So, even though I didn't give you the room underneath it, I want you to remove the midterm and recalculate. If we removed the midterm, we added everything except the midterm, I could literally just retype this without 13.6, or I could have subtracted 13.6 and I would have gotten 71.85, and without the midterm, what is the total weight? 80%. So if you divided that by 0.80, that's an 89.81, and I would round that to a 90. So, yeah. Now, will I remove like your 5 test scores? No. You know, like if you aced like 3 out of 4 tests and had a bad one like early on or something, and then you did, yeah, it's not exactly cut and dry. I mean, like let's say you just had a horrible day. You know, I take that into consideration. You know, but I've had some students that would have like a D average and then suddenly get an A on the final and say, oh, I get an A in the class. No, it doesn't work that way. Now, how do we calculate your grade average? Well, believe it or not, it's actually real easy to do. And it's even easier for you because we don't have plus minus grades here. Plus minus grades you can argue for, but it also depends on the number of credits. How many credits is this course? This is 4 credits. Now, I've had some students that maybe take 2 classes in the summer, and one of them would be statistics. And they would get an A in statistics and maybe a C in English 112. And they'd wonder, why isn't my average exactly a 3.0? Well, because statistics had a higher weight. So it matters for the number of courses, so you don't divide it by the number of courses. Each course has an assigned number of credit hours. For instance, when I took calculus, you know, the grade was an A minus, and it was 4 credits. So the grade points, or quality points, QPA and GPA, they mean the same thing. 3.75 times 4, which is 15. So you're going to find out what the total number of grade points is, and then you're going to divide by the number of credit hours. So you'll do that. Give you a couple of moments to. So calculus, that was an A minus. In statistics, of course, that's an A. 4 credits. 4 times 4, 16 points. Now, of course, if I could only count those 2 grades in my grade average, I would be on easy street, but it didn't work that way. Physics, I got a C plus. So a C plus is 2 1/4, and that's 9 points. Now, chemistry, C minus. Pitt did chemistry. They do chemistry as a separate course and a lab. That's just the way their department worked. 1.75 times 3, that would be 5.25. And then the lab, first time I took the lab, I got a D. And the grade repeat policy worked the same as it does here. What happens is, let's say you take this course and you got a D the first time. What happens is if you were to repeat it and get a B the second time, it wouldn't count twice in your grade average. It would replace the D. Now, it doesn't automatically happen. You would have to contact the registrar. But that's how it works. So, here's the thing. If I add up all these points, 15, 16, 9, 5 1/4, and 1, that's 46.25. Now, you can't just divide by 5 here. How many credits were taken? So the GPA is 46.25 divided by 16, which is a 2.891. So that's what I got that semester. I mean, I can't complain. That was some hard coursework. Any questions about this? Point 8 came from because we removed the midterm. What's 100 minus 20? So the weight is the number of credit hours you've taken. So yeah, I ended up repeating the lab with a different instructor next semester, and I got a B+ for having to do hardly any work, which was nice. And turns out the instructor I had, yeah, he was favoring. All right, distributions. Shapes. Shapes of distributions are real easy. All you have to do here, first off, a symmetric distribution where a vertical line can be drawn through the middle of a graph and the resulting halves are approximately mirror images. Now, they won't be precisely mirror images, but they'll be pretty close. Now, what if the data are not symmetric? They could be skewed or uniform. Data that are skewed to the right have a longer right tail. So in this case, this is what we would call skewed to the left. And this one would be skewed to the right. These look like roller coasters in a way because lift hill has to be, you can't have like a symmetric lift hill. Oh no, you can with some coasters, but like an old school wooden coaster, yeah, lift hill looks a lot more imposing than the hill as it goes down. Looks like that. Now, so you all know the difference between left and right. Now, if you have trouble remembering your left from your right, do this. This forms an L. That means left. If you have trouble remembering your left from your right, that's one way I knew how to do it. I also remember when I was a kid, the shopping center, there was a sign that said no left turn because if you made a left turn coming out of it, you went right into oncoming traffic. So, I'm not going to, if you've ever seen Full Metal Jacket, that's not going to be a left where he slaps the guy, says, now what side was that? Of course, that might be a way to, but no, that's just not right. So, got some practice diagrams for you, and it can be extended to box and whisker plots, which we're going to learn about possibly today. If not today, definitely Wednesday. So this first one, like this kind of black and white one, what would you call this one? I would call that skewed right. How about this brown one? I would call it skewed left. Any questions about these? Just remember, look for the longer side for the tail. And ones that I give you on a test or whatever are going to be much more blatant. Like, I give my own graphs. I make my own using the calculator. It's pretty sweet. This green one would be symmetric. Now, this red one, technically you could call it symmetric. But if you notice, all the counts look to be roughly the same. So what would you call that red one? Uniform. Now, box and whisker plots can also be symmetric or skewed. Just look at the tail. This first box and whisker plot, that appears to be symmetric. Yes? The box and whisker plot? No. If it's a box and whisker plot, you can't consider uniform. Now, one that's on your lab and one that's on your test, I'm basically going to give you either box and whisker plots, and you'll use each of the four once. So you have symmetric for this one, and then this one would be skewed. And the last one would be skewed left. All right, any other questions on these ones? All right. I'm getting my steps today. Working off my food. I'll tell you, tracking your food is a good way to not eat so much of it. Not eat so much crap. That's what has gotten me into some weight troubles, eating crap. All right, we're going to find the range, variance and standard deviation. We're not going to do empirical role in Chebyshev, and we're not going to approximate. So, good news, a little less to do. I've talked to a friend of mine, he's got a doctorate in statistics, so I said, so Phil, what do you think of Chebyshev's theorem? And he says, you actually teach that in a basic stats class? And I said, yeah. He's like, it's kind of pointless at that level. So I said, well, then I'm going to remove it. Coefficient of variation. Now, but that'll be easy enough. So the range is very simple. It's simply the max minus the min. So if a corporation hires 10 graduates, the starting salaries for each graduate are shown. We're going to find the range. So these are the starting salaries in thousands of dollars. So the range is 47 minus 37, or 10, or $10,000. So that's what you're going to get for that. What about the range for this data? Ages in a class. What would the range for this be? 45 years. Yeah, periodically I get a few students that are older than me. Now, the youngest I've ever seen in a college class was a 10-year-old. Was in a discrete math class. Basically, it was a math for non-majors, but we're going to figure out measures of spread. Now, the good thing is we're going to use the calculator to find deviation. Now, namely, we're going to find standard deviation and variance. Now, the thing is, how many of you have heard of mean absolute deviation? I know they taught that in Virginia for a time, but we're not going to be doing that. Now, how do we calculate a deviation? Well, that's easy. A deviation is simply the difference between the data entry itself and the mean of the data set. Now, whether it's a population or a sample, it's calculated the same, no matter what. So, this is the only time we're going to, so basically what happens here is we're going to calculate deviations of the data. This is the only time we're going to do it by hand. So first thing I'm going to do is I'm actually going to go into list 2, and I'm going to enter all of those salaries just by hand. 41, 38, 39, 45, 47, 41, 44, 41, 37, and 42. Now, I'm showing you the calculation by hand of how we calculate standard deviation. But we're actually not going to calculate it by hand anymore. We're going to actually use the calculator after this. But if I do a 1var stat on this list, this time it's list 2, I see that I have a mean of 41.5. So what happens here is I calculate each deviation. Now, some of them are positive, some of them are negative. That's okay. Now, what happens is we're going to end up squaring all of those deviations. Now, you're probably thinking, oh my God, we got to square all those deviations and do it by hand? No. We're going to use the calculator to do that. Now, here's what happens. We're going to get the population variance as, and this is why you don't just write down formulas blindly. What happens is, basically, this part here is what you call the sum of squares. Sum of squared deviations. And you divide it by how many there are. And basically, all you have to do to get the standard deviation is take the square root of that. So, here's what happens. In order for us to find the population variance, we have squared all of this data. And we add up all those squares and divide it by 10, which is the number of pieces of data, plain and simple. And it's going to be 8.85. Now, to find the standard deviation, we take the square root of 8.85 and get 2.975 thousand, or 2,975. Now, here's the thing. We found the variance by doing that, and then we found the standard deviation. Now, we took the square root to get the standard deviation. So, if you look back at our 1var stats for list 2, I want to look at that just again, and here's what happens. If you notice, there is a sigma x. Oh, no, that's Sx. Sigma x. That is the population standard deviation. Now, here's the next question. What if I wanted to go from standard deviation to variance? What could I do then? All right, let me step back a second. If I went to go from variance to standard deviation, we took the square root. What is the opposite of taking a square root? Squaring. So if you took 2.975 and squared it, you would get the variance. Now, that's not exact, but here's something really cool. And this is all going to be in the video. If you go to statistics, you hit vars and choose statistics and choose option 4 and square it. It will be a precise value of 8.85. So you can get that by hitting vars and choosing statistics. Now, that's population variance and standard deviation. Now, there's another form of the calculation that we're going to hit, real quick, which is going to be sample variance and standard deviation. Now you're probably thinking, oh my God, number one, the calculator is going to do it all for you. Now, why do we calculate sample variance and sample standard deviation? Well, there's only one little difference. Even though this formula is a little bit different, it's still the same sums of squares. But rather than dividing by n, you will divide by one less. So how many pieces of data would n minus 1 be? 9. So here's what happens. Oh, wrong one. I don't know why I have both of those out, but so what happens then is we take basically the sum of squares and divide it by 9. And then we take the sample, we take the square root, and that's how we get the sample standard deviation. So if I go and do another 1var stat once more, you'll see that there is an SX, and that is sample standard deviation. Now, just like with population standard deviation, you can square the sample standard deviation and get the sample variance. But the sample variance is obviously going to be a little bit larger than the population variance. And the simple reason why, we're going to see it in much better detail when we get into hypothesis testing and confidence intervals. But it's going to give us a more conservative estimate. Now you're probably thinking, but it's larger. Well, a standard deviation is a measure of spread. It's a measure of how spread out the data are. And a larger standard deviation with using the sample one gives you a more conservative estimate, more wiggle room with things. That's what I like to call it, wiggle room. Now, I want you to, let's just do sample standard deviation for the age data, for age class data. And if you still have it stored on your calculator, good. If you don't, that's okay. So I have that stored in the list number 1. So we're just going to use the calculator and figure out what this is. And if you notice, the sample standard deviation is 9.81 years. Now, keep in mind, standard deviation, again, is how spread out the data are. Now, here's what I want you to do. I want you to now remove the 65-year-old. And recalculate your sample standard deviation. Real easy to do that. Because all you do is you go back into the data and you remove that 65-year-old. So I'm going to go into list number 1 and get rid of that 65-year-old. Take it out. Now, when I go to redo the 1var stats, watch this. What has the standard deviation fallen to? Wow. One outlier has drastically changed the standard deviation. Remember, the standard deviation is a measure of how spread out the data are. Just removing that 65-year-old, all you have to do is, removing that 65-year-old, the data are suddenly not nearly as spread out. Now, last thing we're going to do here is we're going to do this we're going to use the calculator. First thing you'll need to do is find out the mean, population standard deviation, and sample standard deviation. So yeah. So I'm just going to put this into list 3, even though I probably could. $45. I'm putting it in out of order here, but yeah, 49, 51, 53, 57, 61, and 75. Yeah, it used to be I would have you figure out all the deviations and all that by hand, but it's really unnecessary. So I'm going to do this for list 3. And we see that the mean is going to be 50. Now, the population standard deviation is 12.38. The sample standard deviation is 13.05. Now, in order for us to find the population and sample variances, what do we do with the standard deviations? Square them. So you could do 13.04692386 squared and get 170.222. Now that was since I took the square of the sample standard deviation, I now have which variance, population or sample? I have the sample variance. And I could type in all of that, or I could just go to statistics and do this, get the same thing. You can also go to statistics and get the population variance of 153.2. All right, so that's going to do us for test. Okay, so we left off last time talking about standard deviation. Now, variance and standard deviation kind of just go hand in hand with each other. And the simple purpose of variance and standard deviation is simply this. It's a measure of spread. How spread out are the data? You know, if the data has more spread in it, the higher the standard deviation is going to be, and henceforth the variance. Now, your calculators, the TI-84s, do not calculate variance, but basically you just take, how do you go from standard deviation to variance? Not square root, square. So, yeah. So basically the way I would have you doing variance in the past would be do this whole thing where you square the deviations and all that good stuff. But I think we can, kind of just not really concern ourselves with that. Instead, let's just worry about calculating it using the calculator. Or StatCrunch. So here's the other thing with this. Technology, there are various forms of technology that can be used besides the TI-83. StatCrunch can also be used, which happens to be free with your MyLab Stat. In fact, what I'm going to do is, let's see, I won't see on Monday. Wednesday, I'm going to what I'll do is probably today, we'll probably finish today actually. So what I'll do is open up the laptop cart and we can go from there and see what happens here. But basically, the TI-83 and 84 and StatCrunch can be used. Now, the nice thing is when you go to Moodle, you'll actually be able to find a video on there that shows you how you can get started with StatCrunch. It's actually really easy. And the cool thing is, with your Chapter 2 assignments in MyLab, you can actually open things up in StatCrunch and do the questions there if you ever so desire. So you kind of have that little luxury. But we'll get to that. Excel. They've kind of changed Excel a bit, but I also like to use Excel sometimes. Now, the main idea with standard deviation here is, again, it is simply a measure of spread. So you can have 3 sets of data with precisely the same mean. All 3 pieces of data have the same mean. However, in this first set, the standard deviation is 0 because there literally is no spread. And when you have, this is a frequency chart. So like if you have shorter frequencies at the ends, it's not going to be as spread out. But when you have data such as this case, where it's particularly spread out at the end, you're going to have a higher standard deviation. And again, it's a measure of spread. Students always ask me, every time we take a test, what was the mean? And, I tell them what the mean is, but then I tell them what the standard deviation is, because that measures how spread out it is. For instance, if everyone aced the test, if everyone in a classroom aced the test, you would expect the standard deviation to be low or high. What? Now, if everyone aced it, now remember, everyone aced it, that means there's very little spread. So it would be low. The mean would be high. Now, if there was a wide range of test scores, for instance, you had a large group of students that did very well, and then you had a large group of students that did very poorly. That's when the spread would get much higher. So that is the purpose of standard deviation. Calculating it is one thing. You have to know what you're doing with it. Standard deviation measures how spread out it is. For instance, if I were teaching 2 classes of the same thing, like for instance 2 pre-calcs, and typically I would get the same mean, but standard deviations can be much wider. And that's simply because data in one section could just be more spread out. So, with that in mind, we're going to do coefficient of variation for a data set. Now, coefficient of variation, we're going to be able to use a calculator. So, how do we figure that out? Well, basically, it will describe the standard deviation of a data set as a percentage of the mean. So you can do it for a population or for a sample. I will make it, I will tell you which one to use, whether it would be sample or population. And So what happens here is for heights and weights. Now don't think of this as like scatter plot, scatter plot data. Think of this as just individual heights and individual weights. Now, in these two cases, in the cases of the two questions that you see here, the guided example and the one after, you will see that both sets of data have the same number of values. If you look, even though I said, yeah, you don't need to do question number 1 on that lab, if you noticed, the number of data in both sections was different. That's okay. Doesn't have to match. So, in order to find coefficient of variation, it's very simple. All you have to do is take the standard deviation and divide it by the mean, whether you do it for a population or a sample. And how can you find mean and standard deviation? Simple. Calculator. That's all you have to do. Now, in this set of data, we can tell, for heights of basketball players, the mean height is 72.8 inches with a standard deviation of 3.3. So literally you take 3.3 and divide it by 72.8. Multiply it by 100% to get your percentage that you need. And for weights, and again, you will use the calculator under which thing in the calculator enables you to get mean and standard deviation lickety-split? 1var stats, very good. That's going to be one of your best friends in this class. 1var, yes? Basically, all this data was entered, and it was found that the mean was 72.8 and standard deviation was 3.3. 1var stats was done for you. Now, here's what we're going to do, or you're going to do. Well, I'll do it too. We're going to put the heights, let's put the heights into list 1 and the weights into list 2. So do not do 2 variable stats. Just do a 1var stat on L1 and on L2. So we're going to use sample standard deviation here. So that's SX. So our next step is let's enter that data into lists 1 and 2. Entered into our calculators. Now, so we're going to do this for heights and weights. But we have to do it individually. Now, for standard deviations, do yourself a favor and just round them to 2 decimal places. Yeah, and I'll tell you that. I mean, if you go more, that's good, but you don't really have to. So I'm going to do a 1var stat on list 1. Now, list 1 is my default. Making sure my mic is hot. And I have that right here. So that's going to be 2.84. And the mean is going to be 74.32. By the way, 74 inches is how many feet, how many inches? 6'2", my height. Now, in a moment, so now we're going to do 1var stats on the other list. So we're going to go to stat and choose 1var. Now, I'm about to do something incorrect here. And here's what I mean by that. I want list 2, so I do this. And when I do that and go to calculate, I'm going to get an error. But that's okay, because here's what happens. In order to get list 2, you hit second and 2. The 2 is kind of a subscript. Think of it that way, as a subscript. And so we go to calculate that, and we have our standard deviation as 28.23. and our mean as 323.32 pounds. So what I'm also going to do here is I'm going to just kind of bring this over to my screen here. And I need to blow that up so we can see it a little better. Maybe that's a little too blown up. Now, coefficient of variation. So for the heights, we literally take 2.84 and divide it by 74.32, but multiply it by 100%. So we do the math here. 2.84 dividing it by 74.32 and multiplying it by 100 just gets us a percentage, which is 3.82%. Not bad. Now, if we do the same thing for the weights, 28.23 divided by 323.32 times 100%. We see that in this event, 8.73%. So which group has more variance overall? Would you say it's heights or weights? It's definitely the weights. Now, as a percentage of the weight, the mean is 323.32, but the standard deviation is higher. The weights go from 280 to like 370, something like that. I don't know. Now the heights go from 70 to 79 inches. Do they even go to 80? No, but there's just not as much spread in the heights. Linemen are big. You got to be a big guy to be a lineman. All right, any questions about this? Because I will also tell you, you're going to get a question just like this on your unit test. So be ready for that. Yes? Excellent question. Peyton, right? Yeah, excellent question, Peyton. If you want variance, you could just take the square of the standard deviation. But we didn't get variance here. But I can see your point. Coefficient of variation, you might think variance. I don't know what you're thinking, but maybe I'm not going to get into your head. But any other questions? Okay, so now the last section here. So what we're going to probably do over the break is we're going to go and we'll get on laptops and I'll kind of give you a little crash course on StatCrunch as well. So this last section mainly deals with quartiles and box and whisker plots. Now you're probably thinking, oh my God, I got to do another type of plot. But I'm going to show you kind of how to figure out the quartiles by hand and how to interpret that. Now, I don't do z-scores in this. They actually kind of start talking about z-scores in this unit, but then we get into probability, and then we come back to z-scores. So quartiles basically are, each quartile represents 25% of the data. First quartile, second quartile, which is also your median, and then your third quartile. So, but I can also tell you with great confidence, this can all be done in the calculator just as well. So the number of nuclear power plants in the top 15 nuclear power producing countries in the world are listed. we're going to find the first, second, and third quartiles of this data set. Now, first thing you do is you order it. That's if you were doing it by hand. This is more of a explanation of where we get our quartiles from, but we're also going to check it all against our calculator. So here's what I want you to do. I want you to put these into list 3, ordered or not, I don't care. Not that I don't care, but yeah, you know what? I'm going to put them in list 3 unordered. Bless you. So yeah, 7, 18, 11, 6, 59, 17, 18, 54, 104, 20, 31, 8, there we go, 10, 15, and then I think the last one would be 19. So we've entered all that data in. Now, here is a by hand explanation of how we find the quartiles. Now, first thing is we basically find the median by taking the middle value, plain and simple. Now, so the median has split the data into halves, a lower half and an upper half. And all you have to do here is find the medians of the lower and the upper halves. And that is going to be your first quartile and your third quartile. Now, with 15 pieces of data, that's not too imposing. But imagine we had 100 pieces of data. This is when you're going to be glad you had a calculator. But watch this. I am going to do a 1var stat on now list number 3. Now, you probably, you're like, but where the hell are the quartiles? Well, come down here. Look. There they are. So that's how you're going to find it for a test. You will not be doing something like this by hand. So that's how that's going to work. Now, the purpose of quartiles is simple. You know, we're going to find the interquartile range, which is going to be Q3 minus Q1. Now, there is actually a very valid purpose to the IQR. We are going to be finding outliers of this data. Now, if you look, do you think there are any outliers? Which one? 104, and that's the United States. We have the most number of nuclear power plants in the world. And nuclear power is safe unless it's sabotaged or something. So we want to find the IQR, and I would definitely put this on your formula sheet. IQR is going to be 21. Q3 minus Q1. Now, there is a reason we do an IQR, and we're going to see that in just a few short minutes. But in order for us to make a box plot, you're going to find the 5-number summary. So these are 3 of your 5 values. The other 2 are the min and the max. Now, whether or not they're outliers, that's okay. So we can construct preferably a horizontal, but it also can be done vertically scale that includes the minimum and maximum data values, and then plot the 5 numbers along the scale. So what is meant by that? Well, here is, you draw a box from the first quartile to the third quartile. And then the whiskers will extend from the first quartile to the minimum, and then the third quartile to the max. Now, each of these sections, there are, as you can see, 1, 2, 3, and 4 sections. Now, even though there seems to be a high amount of spread, and we are going to verify that, in fact, that 104 is an outlier. That 104 will be an outlier. But basically, what happens here is half of the scores are between 10 and 31. Each section represents a quarter or 25% of the data. That's why we call them quartiles. So, in order for a value to be considered an outlier, we're going to calculate two cutoff boundaries, which we will call the lower cutoff and the upper cutoff. Now, you do not plot them, but we're going to calculate them. So, to find the lower cutoff value, and I would write this down on your formula sheet, you take the first quartile minus 1.5 times the IQR. If there is anything below that, that is an outlier. And for the upper cutoff, you would take that third quartile and add 1.5 times the IQR. Anything above it is an outlier. So, why would we multiply the IQR by 1.5? Basically, John Tukey, that's Tukey, not Turkey, determined 1 was not enough, 2 is too much, 1.5 is just right. So, LC and UC are just my abbreviations for lower cutoff and upper cutoff. Now, my lower cutoff would be negative 21.5. Since I have no values below that, there's no low outliers. However, the upper cutoff is 62.5. Now, here's what's going to happen. You do not plot the cutoffs. Q3 minus Q1. That's your IQR. So, Q3 minus Q1 is going to be your IQR. So, here's the thing. We had no low outliers, so the whisker is going to end here. However, 104 got its own thing. Now, this is going to end at 59 because what is the next value down from 59? I mean, down from 104. It would be 59. But you do not mark 62.5. So some would argue, but 59 is close. Now, guess what? Close only counts in horseshoes and hand grenades. It's either an outlier or it is not. End of story. So, this is how we do a box and whisker plot. Now, here is something really good. This will show you how to do a box and whisker plot. Well, no, this will show you how to find the quartiles. Now, before we move on from this example, here's what I want to do. So here's what I'm going to do here. And I'm going to put this back, but I'm going to remove this 104. Well, actually, first thing I'm going to do is I'm going to do a 1var stat on list number 3 once more. And if I notice, there's my mean and standard deviation. Now, I really care about the standard deviation here. But if we remove the 104 and recalculate. So what happens if we remove the 104 and recalculate? Well, we'll go to Stat and Edit, and I'm going to remove this 104. Now, and I'm going to do a 1var stat on L3 once more, and let's see what happens. Now, I'm not so worried, again, I'm not as worried about the mean, but look what happened to the standard deviation, whether you look at it from sample or population. What has happened to the standard deviations? It dropped big time. So having that outlier in there really makes the data more spread out. You remove the outliers and your standard deviation is going to plummet. So, any other questions about this? Now, I don't have it explicitly drawn. I don't have it like the explicit instructions on how to do a box and whisker plot on the calculator, but I'm going to show how to do it on the calculator anyway. So, remember how we did histograms? You would hit second and stat plot. Now, FYI, in my 171 and 72 classes, if you're using one of my calculators, we haven't done these yet, but starting next week we are. You're going to want to clear out anything you see here. But with that in mind, I'm going to choose plot 1, and this time, instead of a histogram, I have two options for a box and whisker plot. The first one is what you call a modified box plot, where it will show the outliers. The other one will not. But I want my outliers, so I'm going to use that. Now, I don't want list 1, rather I want list number 3. Now, if you go to graph, here's a problem. You don't see anything. So, I'm going to write this down here because, remember, for histograms, you had to putz around with your window values. In this case, we don't have to. For box and whisker plots on the calculator, hit zoom, then the number 9. If you hit zoom and 9, oh, I know what I did. I didn't put the 104 back. I'm going to put the 104 back. That was kind of a boneheaded move. Zoom 9. And that will, believe me, I would love to have that work for histograms, but it doesn't work that way on the calculator. So what you'd have to do, zoom 9. Now, if you've taken pre-calc and used the calculator, what gets you back to a standard viewing window on the graph? Zoom and 6. Zoom 6 is a standard view. You don't really have to worry so much about that. Like 171, my 171 and 172 folks do have to worry about that. They have to know, zoom, zoom 6. But that is basically it for all of our new material. Now, here's what we're going to do. Tell you what I'll do. You'll need to go to Moodle. So we'll go to Moodle. And it's going to sign in, and the internet is slow as H. And I want 152. Statistical methods 1. There is a statistical methods 2. We don't offer it here. I would love to offer that here. And we're going to go to my lab through Moodle. Okay. I have a feeling that StatCrunch might not be accessible as quickly on here. And so here's what I think we might have to do. Let me see. That's eText. I think I'm going to have. I hope it doesn't work this way, because if it does, I'm going to be really angry with the setup. So I'm hoping that I can go to StatCrunch. Course tools, please tell me StatCrunch is here. No. eText. There's Gradebook. Okay. But yeah, go to StatCrunch. If you, I sound a little flustered again. It has nothing to do with you guys whatsoever. But this is StatCrunch. Now, here's what I want to do. Oh, it would help if I turn. There we go. So we're back. So yeah, we should be on StatCrunch now. Now, what I want to do is I want to go into the notes, and I want under var1, I want to enter all 15 pieces of data under this. That's 6, 7, 8, 10, 11, 15, 17, 18, 18, 19, 20, 31, 54, 59, and 104. Okay. Now, so all of the data in StatCrunch. Now, as I said, you might have to just click on here to sign in. I know it's a pain in the arse, but trust me, we're going to get something fixed from Pearson. Somebody's going to hear. My boss has already heard from me, and she said, yeah, don't send them an email yet, because I might get unprofessional. I have to be professional. All right, so here's some interesting tidbits here. So, and by the way, all the StatCrunch hints you need are going to be in Moodle. Now, if you go to Summary Stats, we choose Summary Stats for columns or even rows. I'm going to choose var1. And here's the cool thing. For statistics, I can actually hold down, when you hover over it, it'll tell you Control-click, mean, variance, standard deviation, median, range. I can do a whole slew of things with this. Now it should get you right to this. Okay, summary stats, columns. And summary stats and columns. Okay, I was making sure my mic was hot. So now I can do statistics, mean, variance, standard deviation, min-max, my quartiles, I could even do IQR. I could do unadjusted variance and standard deviation, even coefficient. There's a whole crap load of things I can do. Because here's what happens. I click on that, and so I have all my quartiles. I even did the sum and the variance. Because here's the thing. When I go to my calculator, if I go back and do the 1var stat in my calculator on that particular list, let's see if it matches up, and spoiler alert, it should. But if you notice, the standard deviation they give you here on StatCrunch is the same as the sample. But if you notice that it gives you variance here. And unadjusted standard deviation is basically another term for population standard deviation. So what you do is you hold down Control and click on various attributes that you can carry over. So that's what you can get here. And believe it or, and you know what? All the StatCrunch hints are on Moodle. So it's not like, here it is, suckers, have fun. It's going to be, I can even do a graph. Let's see, box plot. And you can draw it vertically or horizontally. And looky. And you want to see something even cooler? Highlight that, like use a box, and it'll actually highlight the individual outliers. This thing is cool.
Like a calculator that,
it is. It is basically. Now, believe it or not, you can't do box and whisker plots as easily on Excel as you can on StatCrunch. I like to think of it as I love Excel myself, but that's just me. I have some cool things with Excel, but so let's look at this. So now the cool thing is, like, for what's it called? For that first case study that you're going to do, when you do that, you are going to be able to. Oh, you got it to work.
Yeah.
All right. That's all. I was just making sure you were. Just making sure here. So you can easily copy and paste things. Like, you could options and copy, and right click, copy the image. And if I wanted to do that, I can put that right up here. Well, the other instructor said there's no issues. Well, it's cool that we're going to do. So one thing you can do is you can start up another StatCrunch document if you want, or you can close these out. And here's a cool thing. I can rename some data here. Now, if you look at your notes, remember how we calculated coefficient of variation for heights and weights of 25 ball players or whatever? Now, you're probably thinking, oh my God, do I got to type that? The answer to that is no, because I'm about to show you something really awesome. Not this. But, yeah, I'm going to put this back up here. If you go to unit number 1, under this, where it says XLS, you can type in 50 pieces of data on your StatCrunch, or you can open an Excel file. Unit 1. Yeah, it might need to be refreshed. Should be under Unit 1. So you can literally copy and paste the data. Now, and I can rename var1 heights and weights. So yeah, you can open the Excel file and just copy and paste this. Now, you want to see something really awesome. Well, I at least think it's awesome. So, we're going to go to stat and summary stats for columns. Now, if you notice, I have two different columns. So, I have to use a keyboard. See, this is where a wireless keyboard would really be helpful to me at this second. But here's something even cooler. We can calculate mean, standard deviation, but let's look at coefficient of variation. Looky there. Calculates that coefficient of variation for you. Makes our life a lot easier, doesn't it? So, with that in mind, less GPS prices. And when you open that Excel sheet, you'll be able to just copy and paste all 50 pieces of data. And what I'm going to do with this is I'm going to show you how to use StatCrunch to do the histogram. Oh, yes. What you can do to, okay, great question. Peyton just asked a great question. How do I do a new StatCrunch? Go to new data table. Of course, do you have to? No, but I'm doing that anyway because I'm OCD. All right, so there's all the GPS prices. How do you do a new one? Go to StatCrunch and under, where? Yeah, it's somewhere there. All right, good. Now, here's what I want to do. I want to go back to the notes. Now, remember where, so we actually did two different histograms with this. And the first histogram we did, which I believe was on page 5 and 6. What we chose for this one was we had our class boundaries and our class width of 100. So you're probably wondering, oh God, how am I going to do this? Well, watch this. If you go to graph and histogram, we're going to select GPS. Now, here's something cool. We can do frequency, and since we did, straight up 100, $100 ranges, what we can do with this is we could start this at negative 0.5 with a width of 100. Okay, is everyone with me so far? If someone is not with me, well, you know what, you can catch this on the video, but hopefully everyone is with me. Now, we go to compute. Now, if we look, and what I really should do is kind of make this a little smaller here, because you can hover over and get counts and clear it. The counts were 8, 23, 11, 6 and 2. And they match up. Okay, let me see what's up. Histogram. And the start will be at negative 0.5.
Okay, that's what I did. I didn't put
And the width will be 100. All right. So that's how all that's going to work. Any questions so far? Now, believe it or not, we can make another histogram like the second one that we did, where we started that one off at 52.5 and we had a class width of 49. So, believe it or not, we can do a second histogram on that. So another histogram. This time, I'm going to start that at 52.5 and a width of 49. And looky here. So you have 8, 15, 8, and so on. And the really cool thing is you can actually like click on this data and it will display it for you. Yes. The class width. The first one was 100. So here's the cool thing. I can edit that and hopefully you see 49. This was the class width for this one. All right, let me see. Let's see what you got here. Negative 0.5 and 100. Then you compute it. Oh, just make a new one here. Histogram 1, negative 0.5, and then 100.
Yeah, it's still doing 1%.
That's weird. It shouldn't. Oh, you only have 22 pieces of data. You didn't.
Copied it off of the Excel.
You only copied 22 pieces. You didn't copy the whole
Okay.
column.
Thank you.
You got to make sure you copy the whole column here. Oh. Yeah, it's okay. That's what happens. So, yeah, and let me see here. We could even do a frequency table. And again, the directions on how to do this are on Moodle. So if we go to tables and frequency, I could do GPS and I could do a whole crap load of cool stuff with this. Now, but make sure you bin it. Like for the first one, I have this. And I could make another frequency table. Tables, yes. Not on the test, but you can use this on your case study. Because, yeah. I mean, this would be, I'm trying to come up with, a reasonable thing, we could use StatCrunch, but, I also want to see, make sure that's all you're using, but what I want to do, the case study is going to be a huge grade here. Like this lab, case study is going to be worth like 4 of those. So, in fact, what I'm going to do is I'm going to talk about the case study. It's actually a good time to talk about the case study. So, if you look here, where do I have that? Case study 1, and that is due Monday, September the 9th. Now, that's due the day you take your test. So, if you notice, underneath that, there is a StatCrunch help document. So, this case study assignment, we're going to, so here's the purpose of the case study in all actuality. What we're going to do with that is actually going to be this. First off, you'll use Microsoft Word. Now, basically, these are 100 randomly chosen veteran teachers with minimum of 15 years experience in the classroom. So what you're going to do here is you're going to answer a whole series of questions based on this. Now you're probably thinking, wait, I got to enter all 100 pieces of data? No. Because here's why. If you go to the StatCrunch help page, or if we go here, go to StatCrunch help documents, I have an Excel sheet of all 100 teachers and their salaries. You can have it as a data table or one single column. So in other words, you do not have to type in all 100 pieces of data. Just copy and paste. Make sure it's all 100. Don't forget any of them. See, that's a very common mistake though, so don't freak out. But in addition, I made this up here, a StatCrunch help page. Now, this just tells you how to copy the data over from Excel to StatCrunch, and tells you how to do various things. Now, of course, bins and histograms, this is old, this is kind of old here. I tell you in the problem where to start. In this case, I think you'll start at 40,000 as opposed to this. And this will show you how to make a histogram. And here's the other thing. There's helpful hints. And so, now here's the other thing. You copy and paste. Do not print screen things and put them on a Word document and try to submit that. File will be too large. But yeah, what you can do is literally copy and paste whatever you need. Now, here's the other thing. I'm giving you the rubric. This is precisely the rubric that I grade by. When it opens, I got to put a blank one on there. Okay, I did not mean for that to happen, so give me about... and basically what happens is your name goes here when I grade these, and these are all the questions, question numbers. And the cool thing is I don't have to add up the points. Basically, I have everything done here. So this is worth 100 points. Now, you'll notice that frequency table and histogram are some pretty big values. Write everything in complete sentences. When you say, when I ask you what is the mean, you would literally say the mean teacher's salary is $54,200 or whatever. That's all you have to do. I will ding you if you do not give me a complete sentence. And basically, yeah, these are all of the questions you'll be answering. So you'll know, and for the first case study, I'm a little more generous on things. Students have, make a valiant effort to answer the questions and you'll do fine. So there are 12 questions. Now what I would do is, start up a new Word document. And here's the thing. I even tell you how many outliers there are. But for questions 9, 10, 11 and 12, we didn't really go over that in class. Now you're probably thinking, this is kind of a discovery. See, the purpose of a case study is not to just write a professional document, but it is to it's to kind of go a little bit more beyond the scope. Now, does that mean I'm going to test you on this? No way. Like, for instance, what happens is, let's say you give each teacher a raise of $9,000. The help sheet will tell you what to do, or that video will tell you what to do. And what will happen there is, you'll compare, calculate the mean and standard deviation. And it's the same thing. Let's say you give each teacher a raise of 30%. What is the mean and standard deviation? How did it change? And 12, even though we don't do the empirical rule, within one standard deviation, within two standard deviations, and within three. Well, that help sheet is going to kind of explain that. So this has to be typed. And you are permitted to work together, but what I don't want to see, you don't need to print this out and submit it. Submit it on Moodle. But here's a big thing. I do not want to see identically written sentences. And what I mean by that is I'm talking this, I had situations where students literally, not for all questions, but for I had two students that for 4 of the questions, their answers were verbatim. It's like one copied and pasted. And I called them up, and I said, hey, fellas, what happened here? And they at least came clean about it. So I said, well, I'm not going to give you a 0, but these questions are all going to be zeros. So your grade is now, you got a 78 on this instead of 100. So, when I grade these, I try to grade them all in one sitting. So don't just, again, don't do, again, you can work together, but don't like I'm talking like they copied and pasted. Like they literally just, one person's document, he literally just copied and pasted it. Don't do that. It was like the same font. The font changed on the other kid's document. So don't do that. So you do have until September 9th to work on this. So there's that. But yeah, case studies, there's going to be 4 of them. Well, I'll go ahead and just tell you now. The 4th case, as I said, for the test, you will be allowed to bring 1 sheet of notes, front and back. So a couple of other little things I want to talk about here before I get enrolled, get too involved here. I noticed that 2 of you have done the case study. Now, so if you've done that, that's great. You can, it's not due, so you can resubmit if you ever so desire. So you are allowed to do that. So for the test, you can have 1 8.5 by 11 sheet of notes, front and back. And no, there's no layers or Post-its, no, none of that. So I have some old materials here, old labs, old keys, and what have you. So you'll have that in front of you. The case study. Now, I've been getting a few emails about the case study, so this is what I want to really talk about here. So for the case study, a couple of you were saying that you did, you only got 6 outliers, and I realized, that was the case. I don't know what happened, but I only have, so in other words, there's only going to be 6 outliers. So what I've done here is I've actually updated the assignment on Moodle here to indicate that there will only be 6 outliers. Now, the other thing I want to talk about here is if you've already done this, with the frequency distribution, originally it said 50, but if you did it starting at 50, I'm not going to penalize you. So if you've already done that question, don't worry about it. Now, I don't have, I'll set, if you send me your case study, I'm not going to go and check all the answers, but what I want to see is, some of these questions here. Now, a lot of you have been questioning number 12. Like what percentage of the data is within 1 standard deviation, within 2, and within 3. So, here's what I want to do. I want to go to the StatCrunch help documents, and I'm going to pull up the StatCrunch help page. Now, that will help you ultimately with question number 12. So, if you look at the end, the last helpful hint, so you are going to be asked for the percentages. So, this explains it, but I'm going to give you kind of a hypothetical example here. So, and again, these examples are purely hypothetical. I'm not going to give you the actual mean and standard deviation here. But for number 12, and again, we're doing this hypothetically. Let's say the mean is, $71,000. I know it's not that. And let's say the standard deviation, and just round it to the nearest whole number, let's make it real simple, $10,000. Now, it's not going to be $10,000. The standard deviation is going to be 5 figures, though. So, what percentage of the data is within 1 standard deviation of the mean? Well, that's actually really easy. Within 1 standard deviation, basically you do 71,000 plus or minus 1 times 10,000. So basically 71,000 plus or minus 10,000. And the boundaries go from 61,000 to, what would the upper value have to be? $81,000. And basically, how many pieces of data were in this particular question? 100. So you basically just count how many are in between here, and that'll be your percentage. So you can look at the data, you can sort it or whatever, and yeah, between 61,000 and 81,000, let's say there are 81%, 81 pieces. I don't know the exact number. So it would be 81%. Now, if we wanted 2 standard deviations, that's 2. Within 2 standard deviations, you do 71,000 plus or minus 2 times 10,000. Well, simply put, 2 times 10,000 is what? $20,000. 71,000 plus or minus 20,000. And no, there is no plus or minus button on your calculator. I have to say that to my 171 and 172 kids all the time. But we're going to go basically 51,000 to 91,000. That's going to be the range. You simply count how many. But if the data's sorted, you can just, scroll and figure it out that way. So, that's how you do this. The thing I want to tell you, the answer will not be the 68, 95, and 99.7. That's the empirical rule. you think 1, 2, and 3 standard deviations. Some would say, oh, that's the 68, 95, 99, 7 rule, isn't it? No. Well, it is for the bell curve, but we're not doing the bell curve in here. So that's how that's going to work. That I have handed back to you, if you notice, it says now with the key. So you can actually look at that key, download it, and here it is. So I'm going to post keys to everything that we do in this class. All the labs anyway, not the tests. Because the tests you will be able to do corrections on and get half of your lost points back. So that's another, improve the score. Let's say for some reason you did not get a 100% on this first assignment or any assignment. So if you know what's good for you, do not redo any of the questions that you got full credit on. But for instance, I can redo this question, and let's see here. How many store A? 42. So what I'll do is, I would type that in, and there's my answer. Hopefully that's right, and it should be. So the next question. Now here's what happens. I do get half credit for that, but half credit is better than no credit. Most of you completed this assignment at 100%. So it's really moot for you. But basically,